Yeah, I told us that linear equation involve only one unknown, only one alphabet. Okay, so if you look at this expression, uh, we are comparing two sides, or we'll say comparing alphabet to number, okay, or to numbers. Okay, if you look at this side of the equation, this side of the equation contains or have number and alphabet. Okay, this side contain number and alphabet. Here also contain number and alphabet. Like we have alphabet here, we have ordinary number here. We have alphabet here, we have ordinary number here. So this side contains alphabets and numbers, but we will not want that since we are comparing number to alphabet. So what we are going to do is to take all the numbers one side of the expression of the equation, and the one that contains alphabet the other side of the equation. Okay, so they should not be number alphabet one side, number alphabet one side. Okay, so we are going to keep all the alphabet one side of the equation and the other numbers the other side of the equation. But before we do that, let me tell you a rule. Okay, now we have in mathematics we have this sign, this equal to sign. So this equal to sign, there's a rule, okay, that follows it. If you have a plus sign in this other side of the equation, and maybe you want to take this number or this plus sign to this other side of the equation, okay, if you have to cross it to this other side of the equation, it will turn to minus. That is the rule. Okay, the same thing if it has a minus sign this side. If this side has a minus sign and you want to take it to this side, it will change to what? A plus. Okay, that is the rule. Okay, so you have to put this at the back of your mind, okay, or at the tip of your index. Okay, very important. So having known that, all right, so we have to take all the alphabets this side and the numbers this other side. Okay, so how do I achieve that? Okay, already this other side there is an alphabet 2a. Okay, we have 2a here already. Okay, but if you look at this other side, there is a 3a, and we need to bring this 3a to this other side, transfer it from this side to this side. Okay, we will not just take it like this. So we have to transfer this alphabet 3a to what? This other side. And I told us that just now, I told us that this number 3a has a positive sign, okay, but invisible positive sign because there's no minus there. And we have to take it to where its brother is. Okay, I said that let all the alphabets be in one side, then the other numbers stay in one side. Okay, so if we have to move this 3a to this other side, it has plus here. There's an invisible plus here. So if it is plus crossing plus, okay, crossing an equal to sign, it change to what? Minus. So 3a crossing, it can cross like this, it can cross like this. So long as it is crossing, so 3a crossing to this other side will be what? Minus 3a. It is only the sign that will change, the number will not change. Okay, so it was 3a, now it's coming to this other side. Okay, so it will be what? Minus 3a. Don't be confused. Okay, then these are the only two alphabets we have. Then the other ones are what? Numbers. So we'll separate it with equal to. Now after the equal to, what number are you seeing? Is 7 plus 7 or 7. Okay, is 7 you are seeing. So this is what? 7 or plus 7. And then it has a brother. Okay, and the brother is what? Minus 5. Okay, now minus 5 is the ordinary number 8. Need not to be what? Be with the alphabet. It's supposed to be with an ordinary number like 8. Okay, So we will also transfer minus 5 to this other side. Okay, so when we transfer minus 5, it is minus 5, it is not 5. Okay, it's what? Minus 5. So if minus 5 crosses to this other side, I told us the rule: if it is minus and it is crossing, to change to plus. If it is plus and it is crossing, to change to minus. So that is the rule. Alright, so minus 5 crossing to this other side, okay, will be what? Plus 5. Okay, are you seeing it? Plus 5. Alright, so you see that now we have 2a minus 3a, okay, is equal to 7 plus what? 5. Okay, so what we just did is what we call collection of like terms. Collection of like terms. Collection of like terms. Okay, that's what we did. Collection of like terms means take all the alphabets one side and take all the other numbers to one side of the equation. Okay, so what we have now is 2a minus 3a. 2a minus 3a is equal to 7 plus 5. I hope you understand. Okay, so 2a minus 3a, you know this now, you know what to do. They are like terms, so the alphabets are the same, so you can subtract. Okay, so this means you have 2 pen, okay, you are owing 3 pen, so at the end of the day it means you are still owing 1 pen. Okay, so it will be minus a. Okay, don't write 1a, I told you. So it will be minus a is equal to 7 plus 5 is what? 12. So you have minus a is equal to 12. We have come back to that initial state of linear equation, okay, where you have an alphabet, okay, this side, then number this side. So but we are looking for an alphabet. What must multiply by what? By minus, okay, to give us, okay, 12. That is what we are looking for. Okay, so what I'm saying is, how can we make a to stand alone? Okay, and I told us that you always divide both side by what is with the alphabet. So minus a is equal to 12. I'll divide there and I'll divide there by what is with the alphabet. So what is with the alphabet? It's minus. It's minus. I'll also divide that by what? Minus. So that minus divides minus is what? Plus. So we'll be left with what? A is equal to, there's an invisible plus here. Invisible plus divided by minus. Plus divided by minus is minus. Then since 12 has nothing to divide there, I should bring down 12. So our a is what? Minus 12. Are you seeing it? So a is minus 12. That is the answer.